Okay, so we have this question right here. It says a rock falls from rest through a small distance s to the surface of Mars. The rock hits the Mars with velocity vm. And then you have another rock falls from rest through a distance s, same as Mars, to the surface Earth and hits Earth with velocity ve. Now you need to calculate this in this ratio. You have acceleration due to gravity on Mars 0.38 g, and the ratio should be Vm by Ve, velocity of Mars over velocity of Earth. Now let's do this question strategy with a strategy, right? So it's much easier to solve this question. So your first step is to identify what values do you have. So you have Mars. For Mars, you have u is equals to 0 meter per second, and then you have s, which is s, and then you have final velocity as vm, and you have acceleration, which is 0.38 g. Now for Earth, you have the same thing, almost the same thing, which is u is equal to 0 meter per second as s. You have final velocity as ve, and then you have a as g, gravity. Now the second step is to identify which formula can we use, right, to actually get this ratio right here. And we have to select it from the equation of motion. So we have u, we have s, we have v, and we have a. So one of the equation of motion's formula we can use is v square is equals to u square plus 2as. Now let's input the values for Mars and Earth. So for Mars it is vm square. Your u is 0, so you can remove it. You are left with 2a and s. So a 2, and then you have a is 0.38 g, and then you have s as s. For Earth you have ve square, and you have 2 times g times s. Okay, now write this in this fractional form. So you have vm by ve square is equals to 2 times 0.38 g, and s by 2 times g times s. So now you can eliminate this s, right? Let's eliminate some stuff because they're actually the same stuff, right, on Mars and on Earth. So you have same s, you can remove s, you can remove the g, you can even remove the 2. Now what are you left with? You are left with vm by ve square 0 equals to 0.38. Now we still haven't reached to vm by ve. They still have square. So how we can remove the square? We can write this exact same thing like this, vm by ve, but write it as whole square, right? They both are the same thing. If you want to do the comparison, you can just add vm value, some value, and for ve add some value and calculate it. If they are both the same in both of the writing way, whatever, then you know that it is correct and I have written the correct form. So it is equal to 0.38, and now you can shift the square to the other side. So it will be vm by ve square root of 0.38. Now if you calculate this value and round it off to two significant figures, you will have 0.62. 0.62 is your answer. Now to understand significant values, you just see from the values that you have been given already. So from the value of Mars, I can see that they have written their Mars value in two significant figures. So it's a best approach to write your answer as well in two significant figures. Okay, so this is your final answer.